Hi, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar titled Emerging Stormwater Technologies in Rhode Island, the Jellyfish Filter webinar, brought to you by the Providence Stormwater Innovation Center. My name is Leah Soloway from the New England Environmental Finance Center, and I'll be assisting with logistics for today's program, along with Tess Clark from the Syracuse University Environmental Finance Center. Now, in case you haven't heard of the SNEP Network before, the SNEP Network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through the management of stormwater and restoration projects. We focus on building local capacity by providing no-cost trainings, webinars, and technical assistance to communities in the SNEP region. If you'd like to learn more, please visit snepnetwork.org for more information. And now, before we begin the webinar, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. You'll be able to ask questions by typing them into the questions box on your GoToWebinar control panel. We look forward to answering questions, so please type them in at any time. Additionally, you can request a certificate of attendance for joining this webinar. Information on how to do so will be available in our follow-up email after the webinar. We also have closed captions available for today's webinar. To view the closed captions, please click the link in the chat. And also over in the control panel under handouts, we have the presentations available for you to download. And on that note, I'd like to hand things over to Ryan Kopp, the Stormwater Coordinator with the Audubon Society Rhode Island, to introduce our presenters for today's webinar.
Okay, thank you, Leah, and thank you, Tess, for all of your help in the background with technical support for this webinar. For those of you that aren't familiar with the Providence Stormwater Innovation Center, we started about 2 years ago after the City of Providence implemented around 40 stormwater BMPs in Roger Williams Park in Providence. And so we've spent the last 2 years using these BMPs to monitor them, to research them, to try to better understand their function and performance and their overall effectiveness on water quality. We also use the BMPs for public outreach and education by implementing educational signage, giving tours, and hosting various events and festivals. And then we also organize trainings and webinars like this to bring together experts in the field and have them share their information, their knowledge, and lessons learned about stormwater and green infrastructure. So today's webinar is on the Jellyfish filter, and we hope this is the first of a series of webinars related in collaboration with Rhode Island Department of Environmental Management, going through some of their recently approved stormwater technologies. So today's presenters are listed here. If you do want a full, to view their full bios, that is available at the URL right there on this slide. But Brian Burns with the Providence Park Department will be talking about a future conceptual plan in Roger Williams Park to install a jellyfish filter and use it as a training site for maintenance of jellyfish filters. Then Chris Bill will be with the Rhode Island Department of Environmental Management. We'll be talking about their approval process with these new proprietary stormwater technologies. And then Derek Berg with Contact Engineered Solutions will be getting into the details about the jellyfish filter technology and some of the best practices when implementing and designing for the jellyfish filter. And then Hernan Peralta of Woodard & Curran and Brian Giroux of Deprete Engineering will give some examples and case studies of projects that they have worked on in Rhode Island already using the jellyfish filter. So we will break these presentations up with some question and answers. So as Leah said, at any time, type your questions into the question and answer section, and we will be able to, I think we'll have plenty of time to answer them. And with that, I will hand it over to our first presenter, Brian Burns.
Thank you, Ryan. As Ryan said, my name is Brian Burns. I'm the Deputy Superintendent of Parks in Providence, Rhode Island, and a proud member of the Providence Stormwater Innovation Center. And we are interested in a jellyfish filter for a situation we have here in Roger Williams Park. A little bit about Roger Williams Park. In the screen here, you'll see that the lower section is the park itself, the park proper. And the upper left-hand side of this screen, you'll see Mashpee Pond, which is fed by a pond called Spectacle Pond and Tongue Pond. These are all ponds that have impaired waterways. So they're rich with phosphorus and nitrogen and other things. So when the water leaves Mashpee Pond, it finds its way through a pipe that goes through a couple different municipalities and ends up in the inlet shown here, going into Roger Williams Park. So that's a 48-inch pipe that brings all that impaired water here and has for many, many, many years. So not only do we have a problem with the water coming into the park, but we also have a problem with the water that's here now. And the sediment in the ponds themselves are embedded with phosphorus and nitrogen, and the end result of that is cyanobacteria. So this is a very active park. We have a lot of people that fish here, that we have swan boats, we have kayaking, we have all sorts of water sports that take place here. And so certainly from a public safety stance, we need to do better with our water quality. So we can put as many signs up as we want, but the reality is people are going to do what they do. And we need to make sure that when they come in contact with the waters in Roger Williams Park, that they're safe. So to that end, we are continually looking to improve our water quality and removing the phosphorus and nitrogen and other contaminants that make its way into our water. So getting back to the pond, and I will apologize for my rudimentary drawing here. It's not the fact that I am not good at CAD or didn't have time to, but it tells a better story. It tells a story about the Stormwater Innovation Center and what it is. So this is literally a drawing that we made in a conversation with some of the great members of the Stormwater Center, UNH and URI and DEM and DOT. So the basic function would be the pipe comes in from Mashpee, it goes through a couple testing ports, it goes through the jellyfish filter, which we hope will remove most of the phosphorus that's connected to sediment, because that, and again, I'm not going to speak to the engineering of this because there's much more talented people than me on this call, but what we believe will happen is the phosphorus that's connected to sediment will be removed in the jellyfish filter. We are actually calling this a treatment train. We're going to have a secondary facility that we can put different types of removal systems in as they are developed and as we choose. We're thinking we're going to start out with biochar, so many of you may know that, but it'll basically be a concrete structure that we put biochar in, and we test that out for a couple of years, and then we may go on to the next thing. I'm hoping that somebody invents a filter made of mattresses, because we are full of mattresses that have discarded on the streets of Providence that we clean up all the time, and if we can find a way to utilize them, we'd be doing pretty well. So again, just from a conversation with a couple of experts and researchers, we developed this philosophy and this intent to do this. The reason was, and why we led ourselves to the jellyfish filter, is because real estate was at a premium. There's not a lot of area between our property line and where this pipe comes into the pond itself. So the jellyfish filter can be used in a very small area. So this would actually be installed in line in that pipe, in line with the treatment train, with overflows and bypasses that will allow us to deal with the bigger storm events. But in the end, this facility will be right next to Roosevelt Pond. Up on higher from Roosevelt Pond is our casino. There was never any gambling had at the casino, but we do a lot of trainings with the Stormwater Center at the casino. So the hope is to not only install this and get the contaminant removal, but also to provide training and some research about how this functions and what is needed to maintain them. So the Rhode Island Department of Transportation has several of these jellyfish filters installed. As you can imagine, they're installed in highways and not a great place to have a training. So it was a dual cause for us. One, we want the contaminant removal. Two, we want to be able to provide training to a brother agency that really needs it. So that's kind of why we came to the jellyfish filter option. And we think that the treatment train will provide us the contaminant removal that we need, and also provide a training opportunity for Rhode Island DOT. So that's the mission of the Stormwater Center: provide opportunities for all stakeholders to share in their challenges, issues, and struggles. We know that bad construction can be difficult in the actual construction and the maintenance. That bad construction, it's not done right, leads to poor performance, and poor performance ultimately leads to poor water quality. So that's all the things we're looking at here at the Stormwater Center and why we do the things that we do. The Jellyfish option not only is a phosphorus removal, but it's a training opportunity. The biochar is modular, so we can retrofit it, as we said. But ultimately, working together leads to better ways to manage stormwater, and that's what we do here at the Providence Stormwater Innovation Center. So reach out to us at stormwaterinnovation.org and let us know if we can help in any way, and provide us with the information that you've been gathering about what you've been doing in your home or municipality. So with that, I'm going to pass it on to Chris Dill from the Rhode Island Department of Environmental Management. Chris?
I'm coming. Hold on, sorry.
Hi everyone. Do you see my screen? All right, so my name is Christopher Dill. I am an environmental engineer with the Rhode Island Department of Environmental Management. Sorry, the screen is blocking the presentation from me. Yeah, sorry. So like I said, I work for the DEM, and today I'll be presenting about proprietary stormwater treatment technologies in Rhode Island, and you know, how vendors apply, how we review them and certify them. So who is responsible for reviewing and certifying these proprietary stormwater treatment technologies in Rhode Island? That is the responsibility of the Rhode Island Technology Review Committee, which consists of Eric Beck, Nick Pisani, and myself from DEM, along with Elisa Richardson from Rhode Island DOT and Ross Singer from the CRMC. So, are there different types of stormwater treatment technology certifications in Rhode Island? Yes, is the short answer. So there are 3 different types. The first one is a retrofit device, which is basically just you know, something making a old or poorly designed or maintained site better. You know, and we're pretty flexible on our minimum standards and BMP performance criteria for this, because you know, it is still an improvement at the end of the day. And ideally, on these retrofit projects, we'd like to see at least 50% of the water quality volume being captured and treated. But like I said, we are more flexible on those, the performance criteria for pollutant removals. Next, we have pre-treatment devices, and these are used to protect water quality BMPs from getting clogged with things like sediment and trash. And we require that any proprietary pre-treatment device that gets approved has to show at least 25% or greater removal of total suspended solids. You know, these can also be used as retrofit devices. They're not going to get nutrient removal or necessarily bacteria removal either, but it will still, you know, be an improvement, like I said. So that's why it can be used as a retrofit. And another note for pre-treatment devices, previously we allowed them to be used as oil water separators as well if they had greater than 500 gallons of hydrocarbon storage. But we are no longer allowing that anymore because of some recent discoveries that we've made. And last, you have water quality BMPs, which are the, you know, that's the highest level of certification for a device. And they must provide at least 85% removal of TSS, 60% for pathogens, and then 30% for total nitrogen and total phosphorus. And vendors can also, if they can prove with adequate testing that they can get higher pollutant removals, So for example, the Jellyfish, I believe, is approved for 50% phosphorus removal. They can do that, and also they can get approvals for other things such as other pollutants like metals. And down at the bottom, there's the application form that vendors have to fill out and submit to us to start the application process for a technology. Moving on, how does the application and review process work for these proprietary stormwater treatment devices in Rhode Island? So it starts out with the vendor going out and getting third-party verified tape or TARP testing. I'll explain what those mean in a few slides. So they get some testing for their device that shows that they get the pollutant removals that we require. They fill out the application form that I showed the link to on the last slide, and then they submit the necessary materials that are specified in that application form to us. And then the Rhode Island Technology Review Committee, we review the application for completeness. The vendor has an option to give us a presentation on their technology if they so choose. Then the TRC evaluates the submittal and determines if the requirements are adequately met. And from that point, we issue comments and request additional info from the vendor if necessary. And then once we issue our comments, the vendor has the opportunity to provide responses. And if they're not satisfactory, then we're going to issue more comments, and we're going to keep doing that until the vendor can provide satisfactory responses, or their device just won't get certified. If they do provide adequate responses, then the TRC finalizes the certification conditions, which include sizing of the devices to make sure that they treat the water quality volume adequately without bypassing first, things like maintenance and reporting as well. And then from there, we issue the technology certification for that device, and that is valid for 5 years. Once we issue the certification, from that point, we hold training sessions just like this one for review staff in Rhode Island, designers, municipalities, and potentially maintenance providers down the road. So pretty promising stuff. And then, like I said, I was going to explain TAPE and TARP. So TAPE is the Technology Assessment Protocol for the Washington Department of Ecology. They're pretty much the gold standard for testing requirements for the stormwater treatment devices. TARP is the Technology Acceptance Reciprocity Partnership, which consists of a few states throughout the country. I believe Massachusetts, New Jersey, Virginia, California, and a few others. That kind of fizzled out, so it's not really as relevant nowadays. And another thing I should mention too is that a lot of the pre-treatment devices have been going through the New Jersey DEP for their certification on the TSS removal, because they're another good program that has been doing a lot of good work. So applicants that don't have a TAPE or TARP certification already, they have the opportunity to submit reports and materials to us that have to be essentially on par with the TAPE requirements, and that's specified in Appendix J of the manual for stormwater in Rhode Island. But this is really not the best process to go through. We have limited staff, so conducting a full-on review of a technology like this would be a pretty big challenge to take on for us. So it's best to have vendors get that TAPE or New Jersey certification, just so that they can get reciprocity and streamline the process. Some requirements for reporting on the vendor. They have to, the applicant can request a maintenance schedule after the first year of operation. If the technology gets transferred to a different owner, they have to let us know any device design changes or O&M model name number changes, system failures, along with why it happened and how they fixed it. And then annually, we require a list of all installs in Rhode Island with the representative who was there to make sure that it was installed correctly, and a listing of any maintenance providers that they may have trained. After that 5-year period, once it runs out, once their certification runs out, they can get recertified. They have to have adequate reporting throughout their certification period, and provide us with any additional studies, testing, or certifications. And if they have any previous certifications that got expired or revoked, then that can potentially lead to some issues, because we still need to have them show that they still meet the requirements from our rules. So another question you might be having is, what does a Rhode Island stormwater technology certification look like, and what info does it contain? So I'll be opening that up right here. And as you can see, you got the Rhode Island DEM header, Stormwater Technology Program. This is the letter for the Jellyfish filter, which we are going to be talking about today. Has all the vendor info, when it was issued and expires. Then we kind of talk about how the device and its technology application fits into our rules, how it differs from standard BMPs described in our stormwater rules. And then we also explain, what testing was done by who, when it was done, and what, and basically how, again, it fits into our requirements and why we were able to accept it. And right here we have the pollutant removals that it's approved for. Right there you can see, like I mentioned, the Jellyfish is approved for 50%, which is more than the 30% minimum that we require for phosphorus. Get into some general certification requirements, just making sure that they install it properly and use all the right materials and whatnot. Has to be sized to treat the water quality volume, and we kind of explain a little bit of the sizing as well. Can get into that a little bit later with the sizing table. And then we have the maintenance requirements right here. All proprietary water quality BMPs have to be, the entire system has to be maintained once a year, and then their sump, which is required for all these devices, they have to have some sort of sump or upstream manhole to collect sediment. That has to be cleaned out whenever it gets more than half clogged, or at least twice a year it has to get inspected. There's the reporting requirements that I was talking about earlier, and then some other general language. You can see Eric's signature right there. And here's the sizing table that I was talking about. So you have the different Jellyfish models, the approximate impervious catchment areas that they are able to treat without bypassing, and then the associated water quality flow rate that they're able to treat. So for this model right here, if say you had 1/3 of an acre of a parking lot you needed to treat, you would go with the JF 421, and that would handle it, and it would be able to treat that water quality flow rate. And here you have the different size filters with their different flow rates. This table right here is based on the largest size filter, but there's some other language in the certification that explains how you could figure out the water quality flow rates for the smaller filters. And then there's just some general details at the bottom. All right, moving on. So some currently certified technologies in Rhode Island for BMPs. We have the Filterra, the Jellyfish, the Focal Point, and the Kraken. And then for pretreatment and retrofit devices, we have Storm Scepter, Hydrostorm, Cascade Separator, Continuous Deflective Separator, also known as CDS, and Cyclone X. And we are also in the process of reviewing the recertification application for the modular wetlands system linear, which is another BMP that was previously certified in Rhode Island. And this is proprietary technologies, and just stormwater treatment in general are pretty new topics, generally speaking. So it's an evolving world, and just some things to keep on the radar. EPA hasn't developed performance curves for these proprietary technologies yet, but hopefully that's something that they can move forward on in the future. Also, ASTM is working on developing some standard specifications and requirements for these proprietary stormwater treatment devices. I believe Jamie Houle from UNH is going to be pretty heavily involved in that. And then, another thing to mention is that we will be holding more training webinars on other approved technologies. The DEM and Audubon Society and the Stormwater Center and SNEP will hopefully be collaborating on more of these trainings. So I hope you enjoy it. And I guess we'll open that up to questions now. And there's also my contact information. If anyone has any questions about proprietary technologies in Rhode Island, I'd be the person to reach out to. So thank you.
Okay, yeah, it looks like we do have a couple of questions, but feel free to type them in the questions section if you have them. Here's one that says, who is responsible for enforcement that installed technologies are being maintained properly after they are installed? Or does that exist even?
So the question was, who's in charge of enforcing the maintenance?
Yeah, or is there any enforcement?
So as of right now, for all proprietary technologies that we approve, we are water quality BMPs specifically, not so much pre-treatment devices. We are requiring that the applicant for each project submits a 2-year maintenance agreement with a maintenance provider that has been certified by that vendor, saying that they are capable of maintaining that device. So it's at least 2 years into it. Enforcing maintenance has always been a challenge for a lot of agencies, and that's definitely something that we're going to have to pay attention to and try and take care of in the future. But like I said, for right now, we have the 2-year maintenance contract, which is a pretty good start. And
Okay.
Eric, I don't know if you wanted to speak on that at all.
Did you say my name or Eric? Apologize.
We got one other question here that unless Eric, you have anything more that you want to add? Okay, here's the other question. It is, how successful are the recertifications after 5 years? Are certifications frequently revoked after those 5 years? Maybe just how common does that happen?
I think you're muted, Chris.
Yeah, so I actually got started at DM about 1.5 years ago when we kind of rebooted this technology review process. And prior to that, the last round of certifications was about 5 years earlier. So the Jellyfish had got recertified. And like I said, we're working on the modular wetlands recertification right now. Those were the only 2 BMPs that were certified at the time. Getting the Jellyfish recertified definitely took a little bit of a while because, like I said, we were rebooting the program, so we wanted to make sure that we were doing everything properly. And we are also having some hiccups with the modular wetlands, but that's just, like I said, doing our due diligence and making sure that all the boxes are checked and making sure that we fully understand these technologies and how they work and making sure that they get designed properly. But I believe that the 2 devices that were previously certified as BMPs, like I said, the Jellyfish is already recertified and the MWS is on the way. And actually another thing that comes to mind is the Storm Scepter was another one that was previously certified, and that recertification turnover is pretty quick because the pre-treatment in general just tends to be a lot faster of a process than the BMPs because we're, it's like I explained in the slides, there's a lot more that we ask for BMPs to do for treatment. So
okay, that's all we have for questions right now. So yeah, if we want to move on to Derek Berg and his presentation, and we have plenty of time at the end and after Derek's presentation for more questions, so feel free to type them in.
All right, you guys see my screen okay?
yep.
Perfect. Well, hello, everybody. I really appreciate you all taking the time to be here and also appreciate having the opportunity to participate and Certainly thankful for all of the participants and folks partnering to put this together, and most importantly, thankful for DEM and Rhode Island DOT and CRMC for rebooting this process. It's literally, not entirely, but it's a lot of what I do as director of our regulatory operations for the eastern half of the country at Contech. A lot of my time is spent interfacing with programs just like this, working on product reviews and approvals, and sitting on a lot of stakeholder committees. I'm actually part of the ASTM group that Chris mentioned, and I'll just give a quick plug to that, is that it is very active. Jamie Houle is definitely a part of it, among a number of other sort of movers and shakers in the stormwater world. And the end game for some of the initial standards that are going through that program is to kind of feed into what's hopefully going to become a national verification process for innovative technologies. And their grander vision is that it would be applicable to all technologies, but I think there's a recognition that resources are limited, and in a lot of states there just aren't, there isn't time or expertise to go through a vetting process of technologies like these. So most importantly, it's refreshing that Rhode Island recognized that site constraints happen. That's where these types of innovative systems come into play. We can often work around different constraints, fit into a smaller footprint and things like that. So today I'm going to spend the bulk of my time just getting into some nuts and bolts on what the Jellyfish filter is, how it works, some of the kind of core processes and components. I'll get into a little bit of a primer on how systems like this are sized, and as well as talk a little bit about performance data and a quick overview on some maintenance basics, but won't get too deep on any of that today. But I think there is a nice chunk of time allotted at the end of this session for questions, so don't hesitate to type away as we're rolling along, and we'll get to as many of those as we can, and if not during the Q&A, I know I'll certainly do my best to follow up on anything applicable to me specifically after the fact. So get rolling. I thought it'd be a good place to start, just talk a little bit about surface or membrane filtration versus bed filtration. The Jellyfish filter is a membrane filter. You've probably heard of some of the other filters. We actually have another filter in our repertoire that is a bed filtration system. Jellyfish filter is a cartridge filter with pleated membranes in it, and one of the things about membranes is they do a very nice job of filtering out fine particulate. Jellyfish filter is a passive system, so it's not targeting any sort of dissolved pollutants. You heard Brian talking about targeting particulate, but that's exactly the kind of application Jellyfish is best suited for, is particulate and particulate bound pollutants. Whereas if we're talking about a bed or media filter, we can often customize that type of solution. If we get into more specialized situations, we're looking at dissolved metals or nutrients or things of that nature. So with membranes, one of the kind of core principles to keep in mind is that you're doing most of your filtration at the surface. You often have a pretty fine interface that filters out particulate and lets the water pass through that membrane, and it builds up a surface cake. And the nice thing about a surface cake is it actually makes the filter functionally improve as far as its ability to remove particulate over time. But we're going to be very mindful of clogging during the design, and I'm going to talk a little bit more about that. Whereas with a bed filter, you've got a little more leniency as far as clogging goes. You've got interstitial spaces between the media, and you've got ability for particulate to accumulate within the media bed itself. You often can size those at a little bit higher hydraulic loading rate, and I'll talk a bit about more how that kind of plays out in filter sizing in a minute. So a little bit more detail about the Jellyfish. Over on the right side of this slide is a Jellyfish cartridge, and taking a look at it, you can start to get a handle on why it has the name it does. We've got these pleated filter tentacles, if you will, very similar to an air filter, but these ones are long and skinny, pleated membrane, and really the whole point of those pleats is to maximize the amount of surface area in a given footprint. If you were to take a 54-inch long Jellyfish cartridge, there's 11 of those pleated tentacles on each cartridge. They all thread into a base plate, if you will, that's installed in the deck in the system. And there is actually a flow-controlled orifice plate on the top of each cartridge, so we regulate how much flow can get through each cartridge. And the reason for that is that with filters, the way they're typically tested in design is to establish a maximum flux rate or hydraulic loading rate that they can operate at and meet their performance objectives, as well as have a reasonable amount of longevity out in the field. So with jellyfish, we have some different sizes, and it really comes down to, do you have depth on your site? If you've got the depth to go to 54-inch, that's going to be often your most economical option, because quick rule of thumb is the deeper we can go, the smaller we can make the horizontal footprint. So if we had to use a 15-inch long cartridge instead of a 54, you're approaching a 4x increase in the number of cartridges that would have to go into a vault to treat the same amount of water. So the vault obviously is going to have to get it much bigger for that. You see a little bit here about high flow and drain down. I wanted to explain that, and we're going to see some graphics and video that get into that a bit more. But the jellyfish actually has a passive backflush mechanism in it. So at the end of each operating cycle, the system actually backflushes water through most of the cartridges in an effort to maintain hydraulic capacity, knock some of that accumulated debris and caked sediment off the surface of the system. It is passive, it's not pressurized, but it does help extend the longevity. But the drain down cartridges, there's at least one, often more than one drain down cartridge in every system. And you'll get to see how that works, but those are capped at 50% of the hydraulic capacity. And the reason for that is if the drain down cartridges were to clog before the rest of the system reached the end of their useful life, the backflush mechanism wouldn't work properly. So we restrict those to add some longevity to the drain down cartridges. Similarly, you see that there's a column on the right side of this table that lists sediment capacity per cartridge. And that also factors into sizing, and I'm going to talk more about that in a minute, but we don't just look at flow capacity. Filters are much less sensitive to flow than, say, a sedimentation device is, like some of the pre-treatment practices. You can ramp up the flow on the filter and still hit your performance goals, but where you usually suffer is on the longevity side of things. So in a lot of applications, filters end up getting installed downstream of some sort of detention or attenuation where you can really ratchet down the flow. In those situations, we don't just look at flow, we want to look at how much mass is potentially associated with that water quality volume, and make sure we've got enough cartridges to provide reasonable amount of longevity given the amount of mass we're going to treat. So typical system, you kind of saw a few of these graphics. I think Brian had one. Don't feel like you need to figure it all out on this graphic. I'm going to get into more details on the individual functionality or the individual components of the system, but you can see this is a typical manhole jellyfish filter system. Flows coming in through an inlet on the left side, flows into this little pool. We call that the maintenance observation wall, or maintenance access wall, excuse me, because we do provide overhead access directly to that space. So you can insert a backer hose directly into the sump of the system and back it out. That's also where all of our floatables, any floating trash or debris or oil is going to accumulate right in that space. And it serves to provide some pre-treatment to the cartridges themselves. Flow is then going to go down below the cartridge deck. The coarse solids actually settle out into the sump of this system without ever making it to the filter. So it's got a built-in pre-treatment component to it. These systems are designed typically with about 18 inches of driving head across the system. And one of the very nice things about working with a membrane cartridge versus working with a media cartridge is that when it comes time to install and or maintain these systems, these membrane cartridges are much lighter than, say, a wet sediment caked media cartridge. That often is going to require lifting equipment to get it out of the vault. Jellyfish cartridges, even when wet and fully sort of utilized, we can pull those out just with the basic maintenance personnel, and you don't need specialized lifting equipment. So that's one of the big differences between, say, this system and a media filled cartridge, which we do offer as well. So I'm going to fire on an animation clip for you in a minute, and I'm going to pause it a couple of times along the way. But this just gives you another look before I start it up. You can see the inlet on the left. Flow is going to pass down. There's a separator skirt that actually wraps around the cartridge, and I'll show you a good picture in a minute that gives you a better look at that. but it's literally kind of a skirt that hangs down below that deck and provides a level of protection from any oil or scum or debris from getting wedged inside those membranes. And then obviously the heavy stuff that can sink, it's going to go down to the bottom of the vault. Flow passes through those tentacles, if you will, from the outside radially, so it hits the surface, flows through the tentacle into the center of each of those tentacles. There is then a drainage channel that leads up to the top of the cartridge, where flow is then discharged back up on top of the deck and heads out of the system. So I'm going to fire this up, and I'll pause it a couple of times along the way here, but I'm going to turn it over to this automated voice for a second.
Contact Engineered Solutions introduces the Jellyfish filter, an engineered stormwater treatment technology featuring pre-treatment and membrane filtration in a compact system. The Jellyfish filter removes a high level and a wide variety of stormwater pollutants, such as fine particulates, oil, trash and debris, metals, and nutrients. Treatment begins as stormwater enters the Jellyfish through the inlet pipe, builds driving head, and traps floating pollutants behind the maintenance access wall. Water is pushed down to the treatment chamber, where a separation skirt around the cartridges traps oil, trash, and debris outside the filtration zone and allows sand-sized particles to settle below the cartridges in the sump. Water is forced up from the treatment chamber through membrane filtration and into the backwash pool.
So I wanted to just stop right there for a second, just give you another kind of more in-depth talk on the backwash pool and the drain down cartridges I mentioned to you before. You can see the bulk of those cartridges kind of have that little 6-inch high wall around them, and that's what they're referring to as the backwash pool. And we've got, in this case, this is a fairly small system, so the one drain down cartridge located outside of the pool. And what happens is as head starts building on the system, you've got flow coming in. Ultimately, that drain down cartridge will trickle flow up until the point where this backwash pool fills, and then all the cartridges are going to start spilling over and contributing to the effluent. And what this pool really serves as is at the end of the storm event, when we've treated all the incoming flows and the system's kind of reached an equilibrium, that pool of water is then able to push back through the cartridges and discharge out through the drain down cartridges, which are outside of that pool. So that's the passive backwash feature that we're talking about when we speak about that.
Once the water has filled the backwash pool, water overflows the weir and exits via the outlet pipe. The high-performance membrane filtration provided by the Jellyfish filter's pleated tentacles ensures long-lasting treatment and provides a large surface area to effectively remove fine sand and silt-sized particles and a high percentage of particulate-bound pollutants, such as nitrogen, phosphorus, metals, and hydrocarbons.
And just last but not least, I already hit on this, but this is, I mentioned, a fully passive filter. There's no reactive capacity to these membranes. So when we're talking about removal of other pollutants outside of solid, it is strictly the particulate-bound pollutants. And I'll show you some data in a minute. There is actually a growing body of research that a fair amount of the metals and nutrient load in stormwater is often associated with the particulate load, often north of 50%, based on the data that's coming out for a number of these different systems, not just the Jellyfish. Oh, whoops. I think we're just about at the ends, but I will see if I can skip it ahead for you.
Caught in the backwash pool flows back into the treatment chamber through the membrane cartridges. This passive backwash extends cartridge life and keeps them clear for future events. The drain down cartridge located outside the backwash pool enables water levels to balance.
So, all right, just giving Ed, this is just some pictures I wanted to show you, give you, sort of a real world view at some of these components and features. Start down in the bottom left corner of this slide. That's a pretty standard manhole system. You've got a cartridge deck. You can see the backwash pool there around the bulk of those cartridges. This one's actually equipped with 2 drain down cartridges. You can see the maintenance access wall on the left, and there's actually a standpipe inserted in this one, which is pretty common too for anything other than the smaller systems. We'll use that standpipe as kind of a pressure relief and an emergency overflow if we ever got into a situation where the system was clogged and neglected. We certainly wouldn't want to create any upstream issues as a result of that. So we do provide emergency relief in the majority of these systems to address that. Moving up to the upper left, pretty good view of that skirt that hangs down at the bottom of the deck. Your cartridges would be on the inside of that. Again, the intent is to keep the bulk of oils and greases and things that can really gum up filters off of those cartridge membranes. And then circling around top right, similar type of view, just looking right down into the maintenance access wall. That is generally specified as large enough to send a person down into too if there was ever an issue and someone needed to get down in there. And the last one on the bottom right, you can see crews in there installing, the maintenance access wall and the drain down cartridges behind them, as well as the standard cartridges in the drain down pool a little further to the left from that. And then that picture in the center is just looking down the manhole view into a very small system. That's just a 2 cartridge, 1 drain down system. So it's probably a 4-foot diameter manhole, most likely for something that small. Moving along, just a little bit about standard configurations. Manholes are very common, for the smaller projects. We can scale up from anywhere from 4-foot diameter to 12-foot diameter manholes. That's about the limit that most precasters are making manholes these days. And then there's certainly some structural limitations with the decks and things like that on how big they can get. But the general sort of just the sizing is once you know how deep you can go, you know what your capacity is per cartridge, and you can pick out the number of cartridges you needed based on your water quality flow. We also do vaults when we get into big projects and we want to use Jellyfish. There's really quite a bit of ability to go pretty large with the vaults if there's a desire to do so. We can also do multiple smaller units on sites as well if it makes more sense to disperse things. One of the nice things we can do with these vaults, and I'll talk a little bit about online versus offline, is that the Jellyfish filter is typically an offline system. It's not intended to treat flows or have flows routed through it above its water quality capacity or water quality volume, if you will. But when we're working with a vault system, we can do what we call a peak diversion design, where we incorporate a bypass structure into the same vault structure upstream of the treatment bag, so that we can route the water quality volume into the treatment bag and bypass downstream without needing separate junction manholes to do that. On the smaller end of things, we can also design small curb and or graded inlet catch basin style systems. Those are pretty limited at capacity. I think they both max out at four cartridges and a couple of drain downs in a catch basin style configuration. So as I mentioned, this is a pretty standard offline layout for, say, a manhole Jellyfish system. Pretty common for a lot of stormwater systems when we're putting them offline. But does require those junction structures. When we're designing like this, the general approach is to design it so that we've got 18 inches of driving head available between the crest of that diversion manhole weir and the outlet invert in the Jellyfish system itself. And then we're returning flows to a separate junction manhole. So as I mentioned, if we had a vault design in play, we can often put that vault in line and use kind of the peak diversion concept to achieve this without those extra manholes, which I know oftentimes is appealing depending on whether there's constraints or space limitations, or it can be a cost savings too. From that perspective, we do have online design tools and some automated design tools, and I'll kind of steer you towards that. But it's reasons like this is one of the reasons our operating rhythm is to have and prefer that before final designs are in place, people reach out to our design team just to make sure that we're kind of checking all the boxes on what's possible and what makes most sense for the site. Switching gears a little bit, just talk about some general filter sizing stuff. I'm not going to get too deep into things. And the Jellyfish is a membrane filter. So it's a fixed porosity, if you will. I'm sure there are different membranes, but from a generic perspective, when we're talking about filter performance, the type of media and often the gradation of media are going to be a major driver and how well that filter performs. And we also, it's not, again, not so much an issue with an inert membrane, but when we get into specialized media, we want to make sure we're not setting ourselves up for leaching of previously captured pollutants or any sort of toxicity concerns. And I can tell you, during the product development process, we have come across granular media that we have found to have some toxicity. So it's not something that can really be overlooked. It may do a great job of filtering stormwater, but if it's toxic to, whatever it be, in bird macroinvertebrates or other things in your streams, it's not an ideal solution. So something to be aware of. All things created equal, finer media does a better job at filtering, but the finer the media, generally, the more rapidly it's going to clog. So it's always sort of a balance that needs to be struck between those two things. Hydraulic loading rate is really going to be a key factor. As I mentioned when we got started, really the way these filters are designed and tested is to establish the hydraulic loading rate, and it's usually expressed as a flux rate, or commonly in stormwater that's known as gallons per, or expressed as gallons per minute per foot squared of media surface area. And if you recall back, the jellyfish is pretty low. It's at 0.21 gallons per minute per foot squared of media surface area. And we can keep it pretty low and still get quite a bit of flow through these vaults because of all of that surface area we're able to add using a pleated membrane. Something like a granular cartridge filter, the loading rates tend to be a little higher because we have much less surface area, per given cartridge. Within the stormwater industry, the innovative stormwater industry, or stormwater BMP, world is probably a better, more applicable term. We tend to see things between 0.05, very low hydraulic loading rates, all the way up as high as 10. We've never tested or achieved the kind of results we think are needed to meet modern stormwater regulations with anything approaching 10. For some perspective, we have another filter known as the storm filter that's been around a long time, and that one's sized at 2 gallons per minute per foot squared. So, and that's a pretty coarse media. Filter longevity, I already mentioned this, but this really comes into play when we're downstream of attenuation, whether it be a pond, some sort of underground storage structure. It's very common because, especially in the eastern United States, where we get very intense rain events, if it's a small site, treating it in real time, it is feasible, but it can become much more cost effective to attenuate that flow and slow release it from storage because you need a much smaller filter downstream. However, we want to be mindful of the fact that all that water still has mass in it, and if we go too small with the filter downstream, we end up clogging it very frequently, and that's something we try to avoid by switching to what we refer to internally as a mass load design. And that's where, through testing, we try to establish how much mass do these systems handle on a per cartridge or per square foot of surface area basis, before they generally start to clog. Like all things in stormwater, it's not perfect. We have to make estimates of that, and every site has different constraints. And if you've got a lot of oils or something unique going on inside, it certainly can change that math. But we do try to incorporate it into our logic to make sure we're not setting ourselves up for a giant maintenance burden right out of the chute, because that can rapidly erase any savings you made on the actual install of the filter. So a little bit about performance. You heard Chris talking about tarp and tape, and that's exactly the programs that Jellyfish have been through. If you want to talk to states that have programs like this to evaluate innovative technologies, there's very few of them that will even open the door, so to speak, if you haven't been through tarp and now increasingly so tape. For perspective, there's not that many differences between tarp and tape, other than that tape is probably a little more current. It's been updated several times. Both of them came out around the same time. Both of them are long-term field monitoring programs. So we're talking about going out in the field, collecting data over a year or more. Both of them have requirements for the minimum amount of storms you have to capture, data quality, how many samples per storm, how much of the hydrograph do you have to cover. It's pretty involved stuff. It's pretty expensive stuff. Is one of the reasons why data reciprocity is gaining traction, these are north of $200,000 when we're all in, and we start talking about the fact that it's usually done by third parties. All the sample analysis is done by third parties. So it adds up fast, and it's not fast and it's not cheap. So, being able to do credible data studies and then transfer that data and use the local rainfall, for sizing is really becoming the norm within the stormwater world. So the data that you're seeing on the screen here is from a TARP study done at the University of Florida under the direction of John Sansaloni, who's done a lot of stormwater research over the years. You can see the system did perform very well down there, nearly 90% TSS, approaching 60% total phosphorus. Did pretty decent for total nitrogen on that site as well. Nitrogen is kind of a stormwater wild card, and that results tend to vary a bit more than some of the other pollutants, and also did pretty well for metals. Our experience is that when a system is doing a good job on particulate phosphorus, it usually does a good job on particulate metals too, because they tend to bind, to about the same size particle. We've got another study now out of Oregon that was done under the TAPE protocol, as I just mentioned, and very pleased to report very similar results. It's always nice when you can reaffirm what you saw on one site with work done on another. In that particular site, we actually exceeded 60% TP, similar nitrogen results, and similar TSS results. We weren't getting much metals on that site, so we don't have great metals data just because we're getting non-detects for most of the storms. So those that didn't end up getting reported through as part of the study. A few things, just a few select certifications here. Put Rhode Island at the top of the list. That's probably the newest for the jellyfish, but at this point the jellyfish has been reviewed and certified or verified or approved or whatever the local terminology is by the vast majority of programs, in US and Canada that actually have a formal list in place. Both Maine and Vermont also have lists here in the Northeast. We keep talking to Massachusetts and New Hampshire and hopeful they'll do something similar in the future as well. Similarly, New York State, New Jersey, and then down most of the eastern seaboard, Virginia, the Carolinas, all have some form of approval, and similarly out west. And so the list is ever growing, but the data really speaks for itself. Once we get through these difficult, long, expensive studies, usually allows us access to participate in stormwater management in most stormwater programs. So that's kind of the trade-off of doing a long, expensive field study, if you will. Maintenance, another little video clip here. That's a jellyfish tentacle. And when I let this play, you can see there's actually an attachment that you can, unique to jellyfish, refurbish these tentacles and clean them out on site versus doing a full replacement. I'll just let this play for a second. So stop that there. If you've got a massive system with tons of cartridges, that can also be a pretty prolonged process, and different folks prefer to do things differently. You can certainly do a full cartridge exchange. That increases the cost of any given maintenance event, but it's certainly a viable one. There are instances where cartridges just wear out over time. We've had a couple of systems where they were neglected and or had very high solids loading, and the cartridges actually kind of got buried in sediment and shredded up a bit. So that's certainly not out of the realm of possibilities. But we do work with some public works crews that do prefer to take systems back to their maintenance facilities and clean them out themselves. You can do this work on site. It's a little bit messy, but if you've got the equipment and a small system, it's not at all out of the question to refurbish those cartridges on site. Generally speaking, it's all about getting the cartridges, either replacing them or refurbishing them, backing out the sump of the system, and then getting the cartridges back in. It's pretty straightforward. Obviously, the bigger the system, the more involved the maintenance is going to be. Contact doesn't actually provide maintenance services directly, but what we do, you heard mentioned, we do have a certified maintenance provider program where we train them and certify they're quite qualified and understand our systems and all the components and what needs to take place. We've also trained public works departments and DOTs and anyone else, directly that wants, hands-on training from us. We've got videos on that as well. But we have a crew of folks, kind of our field services team, they're responsible if something goes wrong during install, or somebody wants maintenance training. We do have a team of people that provides that service. So I don't have time to go much deeper on maintenance today, but sort of a quick primer on how Jellyfish is cleaned. And then last but not least for me, I mentioned at the start of this that our ultimate preference before the project is in final design is that you do reach out and engage with our team, and we've got on-site engineers assigned to each state. So we've got what we call a stormwater design engineer and a stormwater consultant that are unique to Rhode Island, familiar with all the rules there, the design requirements, what's approved, all the nuances in the letter that Chris pointed out. Then they're going to be sort of your resources to walk any given project through from design to install. But there are a lot of tools on our website. We've got we've got design tool worksheets, DYOS tools if you just need a quick estimate of what you're dealing with, all the technical documentation, more in-depth maintenance, more in-depth information on system performance, and this is true of all of our technologies. So if you're ever looking for basic information, that's the place to start, short of calling one of us up. So I believe that is it for me, and I think we're on to our next question and answer session.
It looks like we have one question that was left over. I'm assuming it's for DEM. It says, can you discuss again the reciprocity with Massachusetts or the lack of reciprocity as it relates, I'm assuming, to certification?
Yeah, so I don't know of any system that Massachusetts really has in place for that. I believe that they just kind of work with municipalities on a case-by-case basis. But
yeah,
like
I can speak to it a little from our perspective, because I've spent a lot of time over the years engaging with Mass, and they're an interesting place in that they're not a delegated state. So EPA Region 1 also has a role there, and the municipalities, all the MS4s roll up under EPA Region 1's umbrella, and the state does have some authority through their wetlands rules. And as far as innovative technologies and reciprocity goes, Mass used to have the Mass STEP database that was up for a long time. It was housed on UMass Amherst website, and they had a whole bunch of technologies like this. Jellyfish was on that, as were a number of other things. But that got defunded 5 or 6 years ago now, and it's kind of created a bit of an impasse. So I think Eric and Chris mentioned you guys are talking with them, but we're talking a lot about them offering some new form of reciprocity along these lines. Right now, they use a lot of these types of systems in Massachusetts. The tricky part, or maybe more so the frustrating part at times, is that it often has to go to a project-by-project review currently. They don't have a fully established list that you can just say you're good to go with these if you size them properly. So that's sort of where it stands. They're absolutely allowed, and depending on which municipality you're working in, they have different preferences and different nuances. But they're using everything from the pre-treatment practices and catch basin inserts to more advanced filters, but they haven't got a fully functioning, sort of approved list at the moment.
Okay, thank you. Here's a couple other questions that can be combined as one. How do you dispose of cartridge cleanings, and is the cartridge excess sediment and stuff washed back into the unit, onto the ground?
Yeah, you do need to dispose of that as you would any catch basin or stormwater sediment, if you will. Every state's got slightly different rules, and I'm not a Rhode Island disposal expert, but no, you need to retain that sediment and dispose of it properly as you would any sort of catch basin waste or forebay waste or anything you take out of your stormwater BMPs. And I know states do have usually some testing requirements, and if you trip over, if you had contaminated sediment, for example, with really high metals concentrations or something like that, or you had an oil spill, that can kind of change the game. But yeah, all that stuff you factor out of the sump and all that sediment, you wash off the cartridges, does need to be retained and properly disposed of in that manner.
Okay, yeah, and it doesn't look like we have any further questions at the moment, but yeah, feel free, audience, to put them into the questions section. And we do have time allotted at the end of the next two presentations as well, so we can pick those up again later. But we'll move on to Hernan Peralta's presentation next.
Yes, good morning, everyone. My name is Herman Peralta. I'm a technical manager with Wood & Curran. So for the first case study, we're going to talk about a project in College Hill, specifically Brown University in Providence, Rhode Island. So the site itself is pretty small, congested. The runoff from the site, discharges into the city separate stormwater. That ultimately outfalls to Providence River, which is an impaired water body for both bacteria and nitrogen. So that was kind of our pollutants of concern when designing these BMPs. So we knew going into the project that the site is very congested with utilities. We knew that there's poor soil conditions. We had some steep slopes that we had to work with based on our project experience around that area. And, with the existing conditions coming in, as well as understanding what the proposed building footprint is going to look like, that kind of confirmed that, designing for and implementing a more traditional BMP would be impractical. So what we did is we turned to the approved list from DEM, and at that time, as Chris mentioned, there were only two treatment that was pre-approved as a standalone system. One of them obviously is the Jellyfish filter, and the other one was a modular wetland. So we ended up selecting the Jellyfish filter for really main reason was that it had a smaller footprint than the modular wetland because of its vertical orientation. So the system is, we ended up designing a JF6, which is a 6-foot diameter Jellyfish system with, I think, 7 cartridges in the unit. And the system was designed to treat the 1-inch treatment depth over 8/10 of an acre of drainage area, mostly impervious, combination of roof, pavement, as well as hardscape areas. So during the design process, a couple of things to consider, and I think a couple of the presenters has already mentioned, like all treatment system, we want to consider whether or not it's an offline and online system. Obviously, offline would be recommended. For a proprietary structures that, again, offline is recommended. It avoids having to oversize the structure to bypass larger flows. For our project, we had to design it as an online for a couple of reasons. So one of them was the fact that the site was very congested with utilities. So we didn't have any room for a diversion structure and a bypass pipe. And so, and the fact that the drainage area was, less than an acre, so it was small enough that we could design this as an online system to allow peak flows of about 4 CFS to bypass through the system. So if you had to design it as an online, do consider the higher head loss through the structure compared to a manhole, standard drainage manhole, because again, there's a built-in weir system in the unit that could potentially create that additional head loss through the system. And like most proprietary structures, they are designed based on a water quality flow parameter. So a couple of things as designers to size the system. One is you can just refer to that table that Chris had referenced in his presentation to size the system. Looks like there's the sizing was based on impervious area as well as water quality flow. Second option, you request contact to, do the calculation for you, and that's what we did for this project. We sent a contact the drainage area, percent impervious, as well as the treatment depth, and they were able to provide us a calculation worksheet that shows water quality flow calculations. Thirdly, what you could do to calculate water quality flow, you can just use the equation that's prescribed in the manual. That's based off the TR55 methodology to convert water quality volume to water quality flow. Other considerations here is, the number and angles of inlet pipes. So for our project, we had 2 inlet pipes with a kind of an awkward angle, but it was great that the structure was able to accommodate the very tight angle between the inlet pipes. And all these design elements, again, the good benefit about working with Contact is, a lot of these design elements can be worked out with Contact with their assistance. Kind of last slide here, the photo to your right is the actual unit that was installed. The project is still in construction. Completion, I believe, is next year. So one of the limit that we found with this unit is that because it has a flat slab, there's not much, it's limited to field adjustments if you have to, for example, lower the structure. So what we did for this project, and actually for the project, the system was located at a prominent area, and the landscape architect that we work with didn't want to see the casting because it's going to be very visible. So part of the design was to install these wonder covers, and the wonder covers would sit on top of the actual casting of the unit, and that wonder cover essentially would match the hardscape area to kind of hide it below the surface. And in order for us to allow flexibility in the field adjustments for the site contractor, is we set the castings about 8 to 12 inches below the finished grade, so that if they had to lower the grade, they wouldn't have to make any adjustments. They'll have 8 to 12 inch of play to use. However, if we had to raise the grade, then we can use bricks or concrete collars to raise those castings. And another installation note is, when the system gets delivered on the site, it has all the internal components except for the filter cartridges itself. And so once the site is stabilized, that's when either the site contractor or the owner would then reach out to Contact to initiate that delivery of the cartridges. So that was kind of a quick case study at Providence. Again, it was pretty straightforward design with Contact. They were very helpful, and through the design process, we were able to manage a lot of the challenges that we face with this site, just because it's again, it's ultra urban, very congested, but overall we went pretty smooth as far as designing it with Contact. With that said, I'd like to turn over to Brian for the next case study.
Thank you. All right, I'm going to talk about 2 different projects. The first project is Project Schooner, which is located in Johnston, Rhode Island. It's right on Hartford Avenue. It's right next to the intersection of 295 and Hartford Ave. So this is proposed as a large industrial building, 800,000 square feet plus footprint. Associated parking, includes extensive improvements to Hartford Avenue, needed safety improvements, widening of over 4,000 feet of Hartford Avenue. And the big problems that we have with this type of site is we're in an impaired waterway, so we're impaired for bacteria and copper. High groundwater, high ledge, like most sites, honestly. Steep slopes, So infiltration areas on the site are very limited. And then with the Hartford Ave improvements, we've got the widening, which is all new impervious area. We've got existing impervious area that's not treated. And we are in a limited right of way. So really not a lot of room to do things. So we proposed jellyfishes in a couple different uses on this project. One use to help increase the pollutant removal across the site was added to traditional BMPs. So actually the middle picture here, we actually added it to an underground sand filter where infiltration wasn't possible, so we couldn't get the pollutant removals we needed. We added on a jellyfish to help get those rates up. And then to other areas along Hartford Avenue and other limited areas like, when your entranceways and stuff go towards a main roadway, it's usually very limited right of way, limited room to do things. We added jellyfishes at those locations to maximize water quality to really the maximum extent. Gave us an opportunity to treat as much as we could on Hartford Avenue, as well as from the proposed impervious from our site. Next project I want to mention real quickly here is Tidewater Landing in Pawtucket, Rhode Island. So this one's actually located right on the Seekonk River. And this was a former contaminated site. So it was a old manufactured gas plant. It's abandoned and cleared today, but it needs to be remediated and capped. So once again, we got a site that's along an impaired waterway, can't infiltrate, and we're impaired for bacteria and nitrogen again. So obviously with any impaired waterway, any increase to impervious area just causes all sorts of havoc with the pollutant loading analysis. So this is where the jellyfish kind of comes in to help get removals that we need. And this site, just like every other site, especially in urban area, actually I'll go back up one, we're maximizing the site to everything. This is right in Pawtucket, it's very urban, and it's the proverbial 10 pounds of stuff in a 5-pound bucket, probably 2 pounds on this site. So the jellyfish really was useful on this site because we have a city drainage line that comes right through the middle of the site that actually has probably close to 10 acres of stormwater coming to it, with 8 acres being impervious. We were able to take that to an offline configuration, and with a 16 by 8 foot structure, which is a really small footprint, able to treat those 8 acres of impervious area and get down to the pollutant loading that we actually need. So this is where we see the real big benefit in the jellyfish is those, really tight spots, really hard to reach areas, really treating that maximum extent practicable because it can do it in a really small footprint and not really be too much of a problem getting it to fit on the site. And that's my 2 quick case studies. I want to pass it back to Ryan.
Okay, thank you, both Hernan and Brian, for sharing some of your lessons learned and when implementing a jellyfish filter. It does look like we just have one question for Hernan about some specifics of where exactly on the Brown campus the project was located.
Yes, the project was for the Performance Arts Center. Again, still in construction. Completion is next year.
Okay. Well, it doesn't look like we have any other questions at the moment. Well, we got some more coming in. Last minute, where did that one go? Here's one about what are some general costs of the jellyfish filter units? That would probably be directed towards Derek.
Yeah, it's hard for me to give you a real defined answer on that one. I don't know the modern price list, if I'm being 100% honest, but it's safe to say there's economies of scale. And by that, I mean, if you just need a couple of cartridges, it's a few $1,000s type of thing. But, when you get into the massive systems, the per cartridge cost starts to go down. But similar to, a lot of these innovative BMPs, they're not cheap per se. You're certainly paying in some cases to save that space. But if you wanted to reach out to me, I can put you in touch with our stormwater consultant who can start to hone you in on ballpark price lists for different type systems and stuff like that. I don't have that information right at my fingertips.
Okay. Here's another one that says, how has recent economic conditions affected pricing and lead times for these products?
Lead times for us right now aren't too bad. We're kind of watching summer, depending on where these things are being shipped from, trucking delays and things like that have been slowing down. And we've seen a little bit of slowdown with some of our precasters in certain parts of the country. But No question, there's been some material cost increases. Jellyfish isn't as impacted. Where we've really taken a hit the last year or two is on steel. We do corrugated steel pipe, so that has actually increased quite a bit in price, but so far Jellyfish has not felt that kind of pressure.
Okay. Now, I don't see any more questions coming in. If anybody in the audience, if they do have questions, you can contact me at the Providence Stormwater Innovation Center, and I will make sure that your questions get out to the presenters so that they can provide an answer back to you. After the webinar today, we will be sending out a survey. If you can take a little bit of time to fill that out, the results of that survey will help us in developing future content and future webinars. And just stay tuned on our website to get an idea of when these next webinars and other events and trainings will be coming out. So thanks everybody, all the presenters and the organizers, and thank you everyone for attending today.
Okay, thanks everybody.
Bye.
Thank you.
Yeah.
Thank you.